Hello, this is Mrs. Pullen for Algebra 2. In this video, I'm going to go over Topical Review Worksheet number 14 on probability. So the first skill that we're going to go on to is combining events and probability. And so if I'm looking for the probability of event A or event B, and this symbol over here means or. Let me just get a pen out. Then I'm going to use this formula, and you do need to memorize this formula. So just take a moment to write it down, and I'm going to take a highlighter to this. This is the probability of A or B is equal to probability of A plus probability of B minus the probability of A and B. This represents the joint probability. And if two events are mutually exclusive, then the probability of A and B is equal to 0. Okay. So number 1, a high school has an enrollment of 1,702 students. In the school, 577 students are involved in music program, 701 are involved in the athletics program. If the probability that a student participates in either sports or athletics is 1,077 over 1,702, what is that probability that they participate in both activities? So if I say A represents athletics and I think there's a mistake in the problem, so I think this should be music. So M as music. They want you to find the probability of A and M. And what they gave you, this 1,077 over 1,702 represents probability A or M. Okay, so because I see that A or M, again, when you hear either, think or, then I know I'm going to use, this is called the general addition rule. So I'm going to always write out the rule on my paper because that's going to help me memorize it. And then I'm going to use my specific letters. So athletics or music is equal to the probability you participate in athletics plus the probability that you participate in music plus the probability that you participate in both music and athletics. This again is called the joint probability. So I know this value over here, A or M. I know the probability that someone participates in sports is 577 over 1,702. I know that the probability in music is 701 over 1702 minus what I'm looking for. So that's both events. So in my with my calculator, I'm going to add 577 plus 701. I can just add the numerators since they have a common denominator. And that gives me 1,278 over 1,702. And now I'm going to subtract this amount from 1,077. And again, I can just do that since I have a common a denominator. So that's negative 201 over 1702 is equal to negative probability A and M. And so now I have that probability. So the probability that a student participates in both those programs is 201 over 1072. And you could round or you can leave the answer as is. A community consists of 580 members. In the summer, and the number of members that participate in recreation sports is 325, and the number that participate in outdoor festival is 182. If the probability that a member participates in either of those sports is 411 over 580, what is the probability that the members participate in both sports and festivals? So that's a similar type of problem. I hear the word or, so I think probability of A or B. So immediately when I hear that formula, I write out the general addition rule, which again you need to memorize. So the more you write it down correctly, the better it gets in the brain. Specifically, I'm looking at, I'm going to use S as sports and F for festivals. So sports or festivals is equal to the probability of sports plus the probability of festivals minus the probability of sports and festivals, which is what I'm looking for. And I start substituting in for the formulas. So the probability of either is 411 over 580. The probability of sports is 325 over 580. The probability of festivals is 182 over 580. Please make sure that you're using proper notation. All these values are fractions and they have the same total of 580. And now I'm looking for the probability of both. And just like before, I'm gonna combine the two fractions. And I get 507 over 580. And I'm going to subtract that from 411 over 580. I get negative 96 over 580 is equal to negative S and F rather. So the probability of both events is equal to 96 over 580. And you do not need to reduce, you do need to show proper notation though. So sometimes they give you the information in symbolic form, as in this problem. And how do I know I'm going to use the general addition formula again? The minute you see that or symbol, most likely that's what you can end up using. And again, we're looking to find the joint probability. And I can tell because of the intersection sign. So I know I'm using the general addition rule. And again, you should be writing the additional rule so it gets into your head. You do need to memorize it for this Topical. And then I substitute in with specifics. And so this is 0.288. I combine like terms. .288 minus 0.97 is negative 0.82. And although that's negative, I'm going to end up dividing both sides or multiplying both sides by a -1. So the probability of both events happening is 0.682. For number 4, in this case, I'm trying to find the probability of B or C. And again, I see that word or, and I use the general addition rule. Make sure you're practicing writing it down because, again, I can't emphasize enough how this is, finding the solution to these problems is not so bad as long as you know the formulas. So in this case, I want B or C. So it's the probability of B plus the probability of C minus the probability of both. This is fairly straightforward, but again, I can't emphasize enough, know your formulas. We're now getting into conditional probability. So the notation is A vertical line B, and that vertical line translates into the word given. And to the right of that vertical line is the condition. So this is probability of A given B is the probability of A and B, the joint probability over the probability of the condition. This is not given to you in the region, so you have to memorize it. So a survey is conducted at Lincoln High School regarding the number of messages sent and received. If a student is chosen at random from the survey, what's the probability that the student texts over 50 messages per week, given that the student is a junior in class? So all of a sudden, I hear that word given, I know I'm dealing with conditional probability. And so you should write out the general rule until you really have gotten the formula into your brain. In this case specifically, I'm looking for the person texting over 50 messages, given that they're a junior. So I first need to get row totals and column totals. So 10, 8, and 3 is 21. So you want to get the row totals and column totals first. You may want to put the video on hold to do that. And I'm getting the grand total, and I double check to make sure that my grand total is accurate, and it is. And so I want, given that the student is a junior, so I'm now looking only at juniors. What's the likelihood they text over 50? So that would be 68, and then the denominator is that condition of the juniors. Part B said, if a student is chosen at random, what is the probability that they're a junior given that the student checks over 50 messages? So probability 50 plus, oh, sorry, probability junior, and then the condition is 50 plus. So in this case, the condition is no longer being a junior. So let me erase that. But rather texting over 50 messages. So the denominator is that 188, because that's the total number of people who text over 50 messages. And of those, 68 are juniors. And so notice the two different values. Okay, so number 6, how do I know I want to use conditional probability for this problem, this formula for the problem? Because I see that A given B here. And so I'm going to write down the general formula. That's always helpful. The condition goes in the denominator. So I know that 0.8 is the probability of A and B. The probability of both is what I'm looking for. And I know I'm given 0.61, which is the probability of B. I can cross multiply, and that will give me the answer of 0.488. Okay. For the next series of problems, I'm looking to show if two events are independent, and there are two ways to do it, and you do need to know both ways. These are the only two ways you should be looking at it, using rather. So two events are independent if the joint probability is equal to probability of A times probability of B. And the second way is the probability of A given B is equal to probability of A. And again, first thing you want to do is get your row totals and column totals. So this is 160. And this is 190. This is 300. Oh, actually, I almost made a big mistake. They gave me the row totals and column totals, so always be on the lookout. Okay, a survey asked 150 students, so that's our grand total. Whether their favorite activity was water skiing, snow skiing, or snowmobiling. Okay, so are the events student is male and student prefers snowmobiling independent? So I'm going to use SM for snowmobiling, WS for water skiing, and SS for snow skiing. M for male and F for female. If you use abbreviations, it should be shown somewhere so the reader understands what your abbreviations mean. It has to be clear to the reader. So using symbols in the table, as long as it's clearly shown, is important. It's also important to have probability notation, proper probability notation, otherwise you will not receive credit. So I could use either rule, either method. I'm going to use method 2 first. And you can do this a number of different ways. You can either have mail as the conditional or snowmobiling. I'm going to have snowmobiling as my condition. So the probability mail, given they prefer snowmobiling. So I'm only looking at those who like snowmobiling, and that was 80 students, and 50 of them were male. And you do need to have a decimal approximation, and that's 0.625. And then I'm going to find, if I want to show independence, then I'm looking, the condition does not affect a chance. So I'm looking to see what's the probability you're going to randomly select a male. Well, there are 155 males out of 325. So I enter that in the calculator, and I get approximately 0.4769. Notice they're not equal, so you would say since probability male given snowmobiling does not equal probability male, the events are dependent. Has to be very detailed and very clear. Okay. Now I'm going to do the alternative method. I could have also done probability A and B is equal to probability of A times probability of B. So in this case, I want to find the probability male and snowmobiling. So that's 50 out of 325. That's the whole sample size if there's no condition. And that's approximately 0.1538. So now I want to find the probability of male times the probability snowmobiling. So that's 155 over 325 times 80. No, that is correct. 80 over 325. And so I'm going to enter that carefully in. And I get about 1174. And notice they're not equal, so you have to make a conclusion since the probability male and snowmobiling does not equal probability male times probability snowmobiling. The events are dependent. Watch the notation. You have to have notation, but notice that the fraction does not go inside the parentheses. Okay. So the following set of problems use this concept of independence. We are given the probability of x is 0.65, the probability of y is 0.43, and the probability of x or y is 0.86. Determine if the events are independent or dependent. Well, where do you begin? Because you don't have the intersection. So you can't directly use the formulas. You're going to start with the general addition rule. So the minute I see the or, I write down the general addition rule and I start filling in. So that's the probability x or y is probability of x plus the probability of y minus the probability of x and y. So this is 0.86 is equal to 0.65 plus 0.43 minus probability x and y. So that's 0.86 is equal to 1.08 and when I solve for probability x and y, I get 0.22. Well, how does that help me? Well, I now know the joint probability I already have probability of x and probability of y. So I'm going to use this rule in order to establish independence. So that's going to be 0.65 times 0.43, and I get 0.2795. Well, that does not equal 0.22. That's that joint probability. So you can say since probability x and y does not equal probability of x times probability of y, the events are dependent. Two more problems. I think only two more problems. Yep. So we know that M and N are independent events, and we're given probability of N is 0.2 and probability of M given N is 0.75. And I want to find the probability of MUN. So and now we're going to use that general addition rule again. So that's the probability of M plus the probability of N. Oh, this is a hard one. Minus probability of M and N. So I know probability of N, but that's about it. But I do know that the probability of M given N, we know that that is independent. Therefore, if M and N are independent, then this joint probability has to equal to probability of M. I'm sorry, not the joint, but the conditional probability. And that means that M is also equal to 0.75. So let me write what I have so far. I know the probability of M is 0.75. I just figured that out. And I know the probability of N is 0.2. And in order for me to get my answer, I need that joint probability. But since the events are independent, the probability of M and N is equal to the probability of M times the probability of N. So that's going to be 0.75 times 0.2. So that's 0.15. So that's 0.75 plus 0.2 minus 0.15, and that's equal to 0.8. There are other ways of doing that, of getting this solution. This is just one way. And last problem, you have the probability that this man pitches is 0.43, and the probability that they have a game tomorrow and the weatherman said that it's going to rain is 0.3. And based on some really crazy calculations, the probability that it rains and the sky pitches is 0.129. So, first of all, what can I conclude? Well, the events are not mutually exclusive, because if they were mutually exclusive, this joint probability would be 0. They're not complements of each other, because that would have to add to 1. So we're either going to show that they're independent or not independent. So since I have the joint probability, I'm going to use this way of determining whether or not the events are independent. So the probability of pitches times the probability of rain is 0.43 times 0.3, and I get 0.129. And since it's equal to the joint probability, we know that the events are independent. I hope this video was helpful, and I will see you soon.